Well, oftentimes, problems associated with multiplication rules show up like this, nary a word "and" anywhere here, just tabular form. And you know that this is a multiplication rule because you see this conditional probability. In fact, we're supposed to find the conditional probability of being a electrical engineer, given that you're male. So let me take you through this problem, and let's do it two ways. Let's do it first, what I would consider the more straightforward of these two ways, but maybe not what's going to turn out to be your favorite. Let's just write down the multiplication rule as it is in this problem. What we've been asked to find is the probability of being an electrical engineer given that you're male. Well, that's just equal to the probability of being an electrical engineer and male divided by the probability of being male. Okay, and we can calculate both of those probabilities right off this table. Oftentimes, by the way, I tend to show this strictly in the kind of multiplicative form, where I take that denominator and put it over there. But there's the way to isolate the conditional probability part of this. So if we're going to calculate those things, I'm going to need to do some totals. I've done these before. I'm not going to do them again. The total number of males here is 2,752. I just added up all of those. I don't really need all of the females, but there they are. And the reason I calculated those because I do need the total number of subjects here. Okay. So with that, I can write down all of these probabilities. The probability here of being an engineer and a male, you just have to go across, look down the column of engineers, look across the row of males, and there are 4,997 out of this total 29,765. I'm going to write it like this. This might give me problems later. I don't know. 765. There's the probability of being an engineer and male, and then I'm going to divide into that the probability of being male, which is 2,752 divided by 29765. Total number of males divided by total number of people. Right? If you were to reach in and ask and pull out one of these 29,000 plus people, what's the probability that you pull out a male? Well, you've got 20,000 males in that bucket. That's the probability. So there's a little bit of an arithmetic issue here. For those of you who are comfortable with fractions, you can see that I can multiply the top and bottom of this fraction by 29,765, and I would just end up with, in fact, I'm going to do that. I would just end up with 4,997 all over 20752. And I'm sorry, I've done that problem, and I'm going to do it again right here. I don't know why, but I'm doing it. 20752 divide, and sure enough, I get 0.241, which is the answer that you're looking for. Okay, so there was the approach using this, going straight forward from the multiplicative rule down to our answer. There's another way to do this that has some real value. I would consider it sort of a shortcut. Remember, what this says is, thank you for your table. I don't want your table. I just want to look at the males. Okay, so if I come up here and kind of blank out the females and just look at the males, I then ask, of the males, what fraction of those males, or what is the probability that if I was to reach in just to the male section and pull somebody out, I would get an electrical engineer? Well, it's the number of electrical engineers there, 4,997, divided by the total number of males. Oh, look, exactly the same thing. right? That's definitely a shortcut. And again, I'm gonna just say it one more time before I drop off here. Remember what that says. That says, given that we're just concerned with the males, forget about everything else, forget about all the data except for just the row of males here. Of the males, what fraction of the males are electrical engineers? Well, it's right there for you, it's 4997. Divide the two, and you get the answer to the problem. Okay, let's move on. All right, this last problem in this particular section of the workbook is a very straightforward conditional probability problem. It says that of the residents of this restaurant, 10% play shuffleboard, 35% play poker, 15% garden, and then it gives you the key that 5% garden and play poker, and it asks you to find the conditional probability that someone plays poker given that they're gardening. So, again, you have to read this problem, you have to imagine what type of problem it is. There's no or, we're not finding, we're not using the addition rule. In fact, when you see given, that tells you that you're looking for the conditional probability. Some such problems aren't quite as straightforward as that. But let's write down the form of the multiplication rule in the manner in which we want to see it. Again, we're interested in the probability that someone who plays poker, the probability that someone plays poker given that they garden. All right, and that's just equal to the probability of playing poker and gardening, number that we're given, times in this case, times divided in this case, sorry, by the probability of gardening. And we've got those things right directly from the problem statement. The problem here is given as 5%, 0.05. The probability here is given as 0.05, and the probability here is given as 0.15. So the number that we're looking for is just 0.05 divided by 0.15. That looks like 1/3 or 0.33333. Okay, so it's really just an issue of reading the problem, understanding the problem, assigning the numbers given in the problem to the elements of the multiplication rule. All right, let's move on.